Hello, everybody. So this is the lecture for week 5, and what we're going to talk about is going to be sections 8.1 to 8.3 from the book, which you were told to look at before week 5. So what these are about, and I'll just click on the book so we can get there, are functions. So if you go to 8.1, you'll see that what we're learning about are just basic functions. And so there's not too much content in here, and if you've programmed in another programming language, it'll be straightforward. And if you haven't, then you'll learn something. But this is the material that we're going to be looking at. So I have a set of lecture slides that are posted under week 5, probably right next to the video that you're watching if you're watching this video. So what are we doing? Well, we'll get right into it. So what we want to know is, what is a function? So a function in computer science is a subroutine. Like, it's a self-contained black box that performs a specific task. Now, you might wonder what the words black box mean. They might be new to you. It's a phrase that gets used quite a bit in computer science. What a black box is it's like something that you don't have to know the inner workings of. You can observe what goes into the black box, and you can observe what comes out of the black box. But what happens inside of the box, you don't know exactly, right? And so, as it says here, you've already been using them, right? Every time you run a function in Octave, you're running a function in Octave. So, like, if I go over to Octave, for example, and if I type, sine 3, right, I get a value, 0.1411. And so the function was named sine, and we put in a 3, and a 0.14 came out. What happened inside of the function? No, we don't know, right? We're not the ones who wrote that function. Obviously, we know what a sine function is supposed to do, but I don't have to know anything about what's inside the function to use that function. So that's kind of the purpose of a function. So there's some purposes listed here. The bullet points are kind of messed up. Um, so one reason we want to do functions is to encapsulate our code, and that's to hide the complex code. Like, it might be really hard to calculate the sine value, or maybe you have a function that's more complicated and even harder to evaluate. Maybe you have a function that takes 100 lines in order to calculate it, right? Well, you put those 100 lines into a function, and then you never have to look at them again, right? You just have to run your function, and all of those lines will run. Another reason is organization, right? So if you have a task, especially a task that you're going to do multiple times, then you want to get that code out of your script and put it into its own function. And that way, your script can look more organized, because every time you perform that task that you're going to perform maybe multiple times, you just have one line of code in order to do it. So that's another reason. Another reason is reusability. So if you write the code once in a function, then you never have to rewrite it again. We just write it once and we could use it everywhere. Okay, so that's why we would want to write functions. Okay, and now the next thing we need to do is we need to learn how to write one, right? We have to write it with the specific syntax that MATLAB expects. Otherwise, our function won't function. So first thing is here, the code needs to be saved in its own im file. So every function is going to be in its own im file, and the file name must match the function name exactly. That includes capitalization, although MATLAB and Octave will both sometimes match the name, even if the file name is not perfect. Um, but that's not supposed to happen, right? You're supposed to match it perfectly. So what does that mean? So if I go over to Octave, let's just make just a test function, okay? Now, in order to do that, I can go to File in my editor. The editor's here, right? If the editor, if you have your editor closed, then you might have to reorganize your window to get the editor back. But we'll switch over to the editor, and you can do File and new script. You could also do new function, but let me show you what that does. So like when I do new function, it's asking me for the name, and then if I put some name, I'm putting test function and I hit OK, then it's already filled in a lot of this for me. And I don't really like that a lot of times. So I'm going to delete that file that I just made. And what I normally do when I'm making a function is I normally just say new script anyway. So just to have a blank file. So you can still write a function even if you do new script. Okay. And so in the file where you're writing your function, you always have to start with the word function. That's how Matlab will recognize that this is a function and not a script. So it looks for that at the beginning. You can have comments. So you can say like, hey, this is a test function, something like that. So that won't like break it. It'll still work that way. Um, then after you have the word function, if there are any return values, you put them here. So I'm going to put y or a return variable, and then equals, and then I need a function name. So the name of my function, I want to call it test function. So I'll write test underscore function. That's just what I've decided to name it. And you know what? I'm going to have two parameters here. So any inputs go right here. So I'm going to say that this function needs an A and an X. Okay. And then there you go. That's my function. And then at the end, you end it with an end, just like you end a lot of things with an end. Right now, just so we're clear, the syntax that we just used was the word function. Then here you have any return variables, which we'll see what those do later, come next where that y is. Then you have an equal sign, and then you have your function name, whatever that is. And then inside parentheses, you have any function inputs. Okay. And now I have to put this in a comment because, of course, this is not valid code. Um, and your return variables are basically your outputs, whatever the function is supposed to output to the user. So, for example, I could right here, I could just make a very simple function. I can just say y equals 100 semicolon. Okay. So this is a very simple function. And if I go file, save as, now you have to be careful here. It automatically filled in test function because it was able to see that I called my function test function. But you need to double check. You need to make sure that the file name and the function name match exactly. So they do. So I can hit save and it should create it over here. And now I've got a function. Now, in order to use this function, well, actually, I'm going to go up here in the A and the X. I'm going to get rid of them. So those were any function inputs. I'm going to get rid of the inputs right now. I saved it again. You can't see that, but I did. And if I run test function, it just returns 100 because that's all we're doing here. Now it returns 100. We would say it that way because I set the variable y equal to 100. And up here, y was listed as the output of the function. So that's why 100 is returned. Now, if I do something else, well, then we could do something else. So let's go back and put the A and the X there. Okay. So now it returns 100 still. But if I try to run it, so if I just press up, for example, and I try to run it now, um, okay, well, let me do it. That's kind of nice, actually. But if we change the function up here to something else, like let's say instead of y equals 100, I do y equals a plus x. Right now it's going to do a calculation based on the inputs. So if I try to run it now, it should give me an error. It doesn't. Okay. this happens sometimes. So Octave and also Matlab does this from time to time too. It's not immune, but from time to time we get into a situation like this where this function right here is called test function, and it's supposed to have two inputs and it computes an output. However, it's not working right because if I do 5 comma 7 here, what should happen is that the 5 is A and the 7 is X. It should compute 5 plus 7, which is 12, and that should be returned. So I should get 12 from this, but you see I get 100. And so what has happened here is that this file has been saved, but like Octave is a little bit confused and it's not using the current version of the function. So if that happens to you, you kind of just have to close Octave. Actually, I saved this several times. So let's try this. File, save. Maybe it just wasn't saving properly. Let's try again. Okay, now it's fine. Never mind. What I was going to say is if you save your file and it does not appear to actually be affecting anything, that you just have to close Octave and reopen it usually, and that will fix your problem. So the function that I have now, whatever comes in, it adds them. So I can run test function and I can just put in, 9 and 9, and it says 18, right? You can put in 9 and 5, and it says 14. So that's a pretty simple function, but it has two inputs, an A and an X, and it has one output, the Y. And yeah, and Y is A plus X. So you write this one time, and now I can run it as many times as I want with different numbers, and I don't have to write new code in order to do that. So let's head back over to the lecture slides. So we talked about this. And then here's a function. So it kind of is onto the second line here, this comment. Like this word input is just the end of this line. It's part of the comment. But so this is a function. It also returns y. The name of the function is times 2. It has one input, x. It computes y equals 2 times x. So this is going to multiply a number by 2. So if I copy that whole thing and I go File, New Script, paste it, you see that, again, this was on the wrong line. So this function doubles the input. Just spacing things out a little bit. So this is our function. And if I go File, Save File As, I'll need to save it as times 2 to match the name up here. And now I've got a new function. You can see it here, times 2.m. And if I run times underscore 2, and I put in, let's say 7, it returns 14. So if you have a mathematical function, it's really easy to do this. All right. So this over here just explains what we've already explained, like the word function here. That's the keyword that tells MATLAB this is not a script. Y, so that's Y. That's the output variable. So that's what gets sent back from the function. Times 2, that's the name of the function and the name of your file. Gotta be careful. Now I say the name of your file, but the file also has a .m extension, just like a script does, which is why you need the word function, right? Think about it. If scripts are in .m files and functions are in .m files, then how does MATLAB know what's a function and what's a script? Well, it has to look for the keyword function. All right, and then X, that's the input variable. So a lot of math functions might have an input of X and an output of Y. Okay. Now, once you save your function, you have to call it. So as we saw over here, like just saving this file doesn't do anything, right? Like you can't run this. If I hit the run button, you'll see it just says error X is undefined, blah, blah, blah. So this does not work by itself. You don't click the play button and run a function. What you do is you have to call it. So if I wanted to run it from the command prompt, you write the name, times 2, and then you put parentheses, and then in the parentheses, you put whatever the input is. So it needs an x, and so you just put in a number there, and then it calculates 2 times that number and returns it, and you get that as your output. And so this right here is called a function call, and that's how you run your functions. Now, I said that you don't, what did I say? I said that you don't click the play button and run it. You might be able to get around that sometimes, like on this text test function here, if there's no inputs like this, and I just change it back to like y equals 99 or something, make sure to save it. If I hit the play button here, this might run, and it does. And it's able to run without, it's able to run with the play button because it doesn't require any input. The times 2 can't do that because it expects you to have an x value, and so you have to type an x value into it in order to get it to run. You're not really supposed to run functions just by hitting the play button, though. You're supposed to run them, call them from other locations like we've done down here. Now, you can call a function from a script, though. So it says like calling your function once saved as times 2, you can call it from the command window or another script, just like a built-in tool, right? So like if I were to go back over to Octave, let's just make actually let's open plot script. So this is a script that we previously used for plotting, and I think it plots a sine and a cosine. So let's just run that. And there we go. There's a sine and a cosine plotted together. I don't really like the circles, so maybe I will uh, change that to be like this. Run it again, save it, and then run it again. And okay, there we go. So we are plotting 2 functions, right? But what if instead of doing y2 equals cosine x, what if I do y2 equals times 2 of x, right? Why not? Just like I can run the sine function, I should be able to run times 2. And this is what I get. It's a bit hard to see, but we still have our sine function, I assume, here, and then our times 2 function is here, which it just takes the x value and multiplies it by 2, which is actually a straight line. Right? That's like our function is basically y equals 2x, right? Y equals 2x. So that's just a straight line. So the point is that like we went through the trouble of implementing times 2 in its own file, and now I can call it from other places like this script. All right, let's go back here. No, let's go back here. All right, so this is just explaining a function call. So you could say, for example, a equals 10, b equals times 2a. Hopefully you can realize that if a is 10, and then we put a into times 2, that b will be 20, right? So you can put in variables. So like, let's just go down here. If I do, a equals 10, b equals times 2a, then you get that b is 20, of course. So there's like some of what we've talked about, I want to remind you of several times. And this is just another slide to do that. So the function is defined in its own M file. Okay. The name of the file and the function must match. You can't generally run the M file, as we saw here, right? You go to times 2, you hit play, and that doesn't work. You get the X is undefined. So it generally does not work to run a function. So why can't you run the M file? Because it is the M file, just defined the function. So the M file is the definition of the function. Defining the function doesn't run the function. So to run it, you must call the function. So we've learned the word call, and you call it from some other script or from the command prompt. And then says it again. You call the function from your own scripts and from the command prompt. That's how you do it. Okay. Now, another thing that's important to understand is that a function has its own local workspace. Okay. And as it says here, this is where most beginners get tripped up. Functions live in total isolation. What does that mean? What that means is that in their private workspace for each function, a function cannot see the variables in your base workspace. So what you see when you're looking at MATLAB, you see some variables that exist. That's your base workspace. Uh, those variables are not accessible by your function. So the function cannot see those variables. Um, and this is actually a safety issue, which means because your base workspace has its functions and because your functions have their own workspace, then um, the variables won't kind of interfere with each other. So, for example, if I come down here and I say like x equals 199, okay, so x is 199, um, but then I want to run times 2 and I put in 3. I didn't spell the 2 right. Times 2, 3, you get 6. But in this function here, in times 2, there's a variable called x. But this variable called x and this variable called x are not the same variable x. So if I check what x is equal to here, it's still 199, even though inside of the function, when we call times 2, 3, 3 is x. Doesn't matter, right? The x inside of the function and the x inside of MATLAB, the MATLAB workspace, are different x's. So every function has its own variables that are different than the variables that are here. So it's perfectly okay to have like a variable called x that does one thing inside your function and a variable that's called x that does something completely different just in your MATLAB workspace. All right, back here. So other programming languages have this exact same concept. They refer to the concept as scope. So every variable has a scope where it is visible. So the scope for a function is just that function. And so they refer to functions inside of variables as being local variables. So if you go here and you say, we're not using it for anything, but if you say A equals, 9999, and, we can save that, save it, and come down here and we can run times 2 again and put in, I don't know, 5, and we get that the answer is 10. But even though this says A is 999 and we ran it, if you check what A is down here, A is still 10 from back here. So this A is 10, this A is 9999. They are not going to interfere with each other because this A equals 999 is only existing inside of this function. All right. So this is just kind of a more thorough example, I guess. And so this is an example that our textbook likes to use. It's from chemistry. So there's a formula called the ideal gas law. And so the way you memorize it in chemistry is PV equals nRT. And these all have meanings. So P is like the pressure of a gas. V is the volume of the gas. T is the temperature of the gas, I think in kelvins. Um, and then N is actually how many molecules of the gas there is. And R is a special constant that relates them all. So pressure, volume, temperature, number of molecules. Actually, it's like number of moles is how they normally will give it. Moles is a unit of measurement for number of molecules. And R is a constant. And you could take this and it's an equation, so you can rearrange it. So you could, for example, solve it for P by dividing, put the V on the other side. And we can write a function that looks like this. So if I want to write this function here, this function in a function, I can do it with this code. So I'll just copy the code and we'll head over to Octave here. Okay, so again, I'll do file, new script. Again, I'm going to keep doing new script instead of new function. Paste it right there. Um, just spacing it out again to make it easier to look at. So we have P equals N times R times T divided by V. And there's four inputs, N, R, T, and V. So if I save this, I have to give it a name. So I have to go File, Save As, and it's called idealgas.m because the function name was ideal gas. Now that it exists, I can call my function. So in order to call it, I can't just type ideal gas, right? That won't run because it needs an N, an R, a T, and a V. So you have to put parentheses and give it all those things. So like maybe N is 1, maybe R is 0.8. It's not, it's a constant, but I'm putting that in anyway. Maybe the temperature is 273. Maybe the volume is 1.0, right? So it doesn't matter if these numbers make sense for the problem. The point is that there's four spots for numbers, 1, 2, 3, 4. And I put in 1, 2, 3, 4 things. And when I do that, it can calculate the pressure. Now, I probably should have had a semicolon on the end of that because without the semicolon, you can see it says P equals 218, and then the answer was also 218. We don't need it twice. So I would normally put a semicolon there. And then that way, when I run it, I have to save it. That way, when I run it, we only see the answer one time. Okay, so this function has four different variables that it needs in order to run. Now it says like what file does this code go in? And you should know that if the name of the function is ideal gas, it should go into a file called ideal gas. All right, now how do we do this? Well, once we have a function, maybe we want to use it for some calculations, right? So we can make a script now. So I'm gonna say this is a script to test out our ideal gas function. Now, I don't know anything about chemistry. I don't know about you, but we'll just copy it. So let's look, see what we have. So to start with, put these on different lines. And this is just a variable. It actually is, like I said, uh, number of what they call moles of gas. This is a constant related to gases. We have temperatures. Now, just so we see what this does, I'm going to copy that one line down here to look at it. So you can see when you do 300, 100, 500, we're just going to go 300, 400, 500. So this is just temperatures. 300, 400, 500. Okay. And then volumes. I think I might have to fix our code a little bit in the other function. Uh, so this is some volumes. It's like 0 0.01, 0 0.02, 0 0.03, up to 0 0.1, it looks like. Okay, so we have NRTV, and then we have some code here that's going to go through and supposedly run our function. May or may not work. Like I said, I think I might have to fix a typo in our function. Now, this is a script. So I can save this with any name I want. So if I go File, Save File As, I can call this something like ideal gas script.im. You don't have to put the name script in the name, but I am. And so now it has a name. This is a script, so I should be able to hit the play button. Although, like I said, I'm not sure that the code will run. Let's try it. So the reason it didn't run was because if we go over to our, you could see error operator slash non-conformant arguments called from ideal gas. So you head over to the other file. And the issue is that looking at this, we have t as a vector and v as a vector. And so in order to make this work, we, um, let's see here, we will have to make this division with a dot in it. So let's try that. I need to file, save, and then head over here and let's try to run it again. There we go. So here's our plot. So you see, we wanted to know maybe how pressure and temperature were related. And so we made a plot of, it looks like we put the volume on one axis and we put the P on the other axis. So, you could make this better, right? Like when we plot it, um, we can do like line width 1.5. Is that better? That's better. Of course, we can do a legend. And what could be in the legend? Well, I think the legend was it looks like we're plotting this for each temperature. So I think the first one was T equals 300. And I think the next one was T equals 400. I think the next one was T equals 500. See what this looks like. Okay, we got a legend here. So the hotter the gas, I guess the bigger something is. I guess we need or label. So X label looks like the x-axis is volume. Volume. The y-axis looks like P, which is pressure. I don't know what the units are because I'm not a chemistry person, but I can at least fill these in. And you can see we get a graph. If we got pressure here, we got volume here, I've got a legend here, etc. And so this is our normal stuff that we do, right? When we're um, making plots and things. The only difference between this and what we've done before is that we are using our function ideal gas in order to perform the calculations rather than just performing the calculations right here in the script. Okay, so let's head back to here. And I think we're just about done. So what did we learn today? Well, these are just, actually, this isn't what we learned today. These are just things to keep in mind. So when you're writing a function, make sure that the function file name matches the function name. So file name, function name, same. Did you remember to write function at the beginning? All right, am I passing the inputs in the correct order? That's important, right? Like if you have a function of x and y, make sure you know if x comes first or if y comes first. Otherwise, you'll be putting the numbers in the wrong place. Remember what happens in the function workspace stays in the function workspace. So again, when you're looking at here, um, these variables that are in your script, right? This is the script in our TV. These variables are in a script and they show up in the normal workspace. However, in the ideal gas function, the variables were in our TV. But these in our TV here are not the ones in the function workspace. The NRTV here are ones that are internal just for the function's use. Okay. And yeah, that's it. That is our first lecture on functions. So hopefully this is helpful to some people, and I will talk to you guys later.